Welcome back to Dr. T's Algebra 2. In this video, we are going to move back and forth between standard form, vertex form, and factored form. So we started our parabola here, y equals x minus 5 squared plus 2, and then we got it into standard form, x squared minus 10x plus 27, by expanding this using the FOIL method or the snowflake method or the box method, and then adding this constant on the back to get 27, which is our y-intercept. And so we're in standard form now, but how do we get back to that? If we're given standard form, how do we get back to that x plus or minus something factored form? Well, the first thing we need to recognize is our signs here. If we got ax squared plus bx plus c, if we are plus minus, like ax squared plus bx plus c, then we're going to be working with a plus minus in parentheses. If we have minus minus, likewise, we're going to be working with plus minus in parentheses. If we have plus plus for our standard form, then we've got plus plus in factored form. And if we've got minus plus in standard form, then we've got minus minus in factored form. And that's where we start. Now, let's look at factors of 27. We've got 9 times 3 and 27 times 1. That doesn't really help us a whole lot because the sum of one of these pairs, and we can't mix and match, it has to be the pair, but the sum of one of those pairs has to equal the b term in our standard form, and the product has to equal that c term in our standard form. And any way we spin it, if we got plus 9 minus 3, we know that we're going to be working with plus minus. Here we got, we're going to be working with minus minus because we got minus plus. 9, the absolute value of 9 plus 3, or negative 9 minus 3, is not 27. And then the absolute value of the sum of 27 and 1, whether negative or positive, is 28. So we got 12 and 28, which is not equal to 27. And so this is solvable then through the quadratic formula maybe, but it's not easily solved just by simple factoring. What we've got to do is complete the square. To complete the square, what we want to do first is move this 27 over to the other side of the equal sign. So we got y is equal to x squared minus 10x plus 27. Now, if we are factoring, we're looking for roots. So we can just set y equal to 0. So 0 equals x squared minus 10x plus 27. Let's just take and move that 27 over to the other side. We undo addition with subtraction, minus 27. So we'll get negative 27 is then equal to x squared minus 10x. Now, that b term, negative 10x, we're going to divide that by 2 and square it. So b over 2 squared is what we're going to add to both sides. B over 2 squared. In this case, b over 2 squared is 5 squared, which is 25. Add to that 25. Add to the other side 25. What you do to one side, you have to do to the other. And so if we add 25 to both sides, we get negative 2 equals x squared minus 10x plus 25. Now we've got an easily factored trinomial, because our c term is just b over 2 squared. And so that's what we know will result in something like this. x minus 5 times x minus 5. We take the factors here, we got 5 and 5, we got 25 and 1. And remember, our sum has to equal 10. We're at minus plus, so we've got minus minus here in parentheses. Our sum has to equal 10, and our product is 25. Well, obviously, our sum equals 10 there. And so, set that all equal to negative 2. And this should look familiar now, because we can move this back over to the other side. Move that over to the other side with addition. And we end up with something like 0 is equal to x minus 5 squared plus 2, which is back into our vertex form. And so ideally, what we're going to have is a 0 is equal to some parentheses, some parentheses. Then we can split it up, and we get 0 equals the first set of parentheses, and 0 equals the second set of parentheses, and we'll just solve for x from there. But in this case, we had negative 2 is equal to those two sets of parentheses. And we could graph this parabola. If we graphed it, which we did in the first case, in the first video, we saw that our vertex is 5, 2, and it's opening up. And so we know there are no roots. There are no x-intercepts here. If it were opening down, that would be a different story. But in this case, it's not opening down, and we don't have any roots. And so the quadratic formula would show us that we don't have any real roots. And then solving this expression is just going to yield nonsense, because there are no real roots. In another video, we'll show how to find the roots, how to work from factored form to the graph, and then how to work from the graph to the factored form. All right, this is Dr. T's Algebra 2. Thank you.